Today we build this. Okay, today we start to actually do the unboxing, the assembly, and the review of the Oxgear 1500 by 1500 mechanical kit from MakerStore. To give you an idea of the delivery time, we ordered this on the 10th, it shipped on the 14th, and arrived on the 18th. The inside of the first box, we had bags of all of the parts. Everything was pretty much packaged very nice. There were individual bags inside of the larger bags, and everything was well packaged. The ox plates came together as well in a nice little kit, wrapped up. Lots of bubble wrap, lots of foam. Everything was well protected. Everything was in one piece. Didn't find any issues with the packaging in this first box. The second box had the extrusion rails and a few miscellaneous parts that were not in the first box. Again, the box was very tight, very well wrapped around the product. Nothing there was a concern. On each end there was styrofoam, but as you can see, the styrofoam that they used sort of really fell apart, got stuck into the extrusion rails. I actually suggested to them they may want to use a different type. There was nothing really damaged, but it was something that was a little bit, it was a thing of a concern. Wrapped all around it, they had a nice amount of cardboard, bubble wrap, lots of plastic, lots of tape. So everything was very well wrapped and protected and appeared to make it through the shipping process in one piece. Like I said, the one thing that was a concern was on each end, the styrofoam that they used just completely crushed in shipping, and that was the one thing that could have been better. As you can see, we had a few miscellaneous parts in here. The majority of the parts were in the first box, but the NEMA motor mount, the one you actually mount your motors to, the Z-axis screw, I forget what you call the thing, and the rack and pinion system for the rails that you put into the rails for the motors for the gears to run on for your Y-axis, all of those were in here. These individual extrusion rails, they were actually individually wrapped for the most part in some type of protective foam or bubble wrap. They were taped together, and it was a very tight bundle. Everything was wrapped together very well, and I really had no concerns or problems with that. The one thing with the tape that they were using is a lot of that tape wound up directly applied to the rails, which was a downside because there was a lot of adhesive left over afterwards. And so it took a lot of acetone cleaning to get all of that tape off of the rails. So other than that and the styrofoam, I saw no problems with the way everything was shipped and was perfectly happy with that. And with that, we are through with part one, the unboxing. Now it's time to move on to part two, the assembly. So let's move on. Okay, in step one of the assembly, we had to put together the 42 wheels that will be used throughout the project. Each wheel was individually bagged and basically consisted of a small rubber wheel, well, hard plastic, 2 bearings, a shim, and a nylon lock nut that will be used throughout the project. Basically, it's a fairly straightforward process. You simply snap the 2 bearings inside of the plastic wheel with the shim in between it. One thing I did notice was that the shim could shift and kind of block the hole. So what I started doing was actually assembling them on a screw. So I just took one of the M5 screws and started to assemble them on top of that, and that helped to ensure that everything was lined up properly for later on. Once I figured that step out, it seemed to work very well, and then I continued through basically building all 42 of the wheel assemblies. Next, we moved into step 2.0, part 1. This is where we start building the Y-axis gantry. This is for lack of a better word, the part that rolls back and forth on your C-beams to allow your Y-axis to go back and forth. Basically, there are 2 sides to this, and it's going to be mirror imaged on each side. The first step of this is going to be installing the wheeled assembly itself, and then the second part is going to be installing the motor assembly on the outside that will later allow it to ride on the rack and pinion system. Okay, so this is a fairly straightforward procedure. Basically, your M5 bolt goes through the aux plate, and then it is followed by a spacer, a shim, a wheel, a spacer, a wheel, a shim, and a spacer. One side uses a regular aluminum spacer, and the other side uses an eccentric spacer. Basically, the eccentric spacer is an offset, non-centered nut that allows you to tighten and loosen the wheel assembly to properly hold onto the C-beam without being too loose or too tight. So one side, the M5 screw is centered in the hole, and the other one, it goes through the eccentric spacer that allows you to loosen and tighten. Once that part is done, you basically repeat for a grand total of 14 axle assemblies, 7 on each of the 2 aux plates. Once you've installed all of the wheel components onto the M5 axle screw, you then put on the back side aux plate. Basically, this plate sort of helps hold everything together, and then you complete it off by adding in the nylon threaded nuts that were in the bag with your wheel kits. This basically completes the part that kind of holds all of this together, and once this part is done, you are basically through with step 2.0 part 1. I did want to provide a little bit of information that I learned when doing mine. As you see here, it's possible by just tightening these down, even with the eccentric nuts fully expanded to the wide open position, that your gantry may not fit onto the C-beam, and that is because there's a little bit of play in the holes. And later on, I found out that basically if you go in and loosen all 7 of the axles up on each of the gantry trucks, slide your gantry component onto your C-beam, and then tighten your axles down, it will fit much better. So it is possible to, at first, basically not be wide enough to go onto your C-beam, and then later on you can basically fix that by just loosening up those axles, sliding it on, and then tightening them back down. It appears to be just basically the fact that there's play in the bolts, because everything can't be perfectly tight fitting, so that little bit of play is just enough to keep them from going on. On to step 3, or 2.1 part 2. And just a quick side note, as you see here in the arrow, it now says for an Australian system you get a 27mm M5 screw, and for the US you get a 30mm. This is actually one of the things that after we reached out and asked them, hey, did you send me the wrong thing? That's when they actually updated this. So like, oh yeah, in the US market it's a different part. So the company has been very responsive about fixing their wiki with things that we have found through this project. So this is one of the advantages of having a wiki-based system. This is the second part of the gantry assembly, where we actually install the NEMA motor brackets and the assorted tensioners onto the system. Basically, this is what allows the motors to flex without actually damaging anything and riding on top of the rack and pinion system. Quick side note, if you're thinking about leaving these off until the end of your project just so they're not sticking out and everything else, don't. The bolts are not accessible. Once this is installed onto the C-beam, you cannot access those bolts and you will have to pull it off. Ask me how I know. Okay, and as you see in this step, we are inserting an M5 bolt, adding on a spacer, some washers, and attaching the L bracket and connecting it with a nylon nut. This isn't going to be super tightened down, but once everything is complete on both of the brackets, we then tighten it down so that we can get everything connected. Before you completely tighten down this nut, you'll want to go ahead and kind of angle that bracket the way it needs to go, just so that it isn't too much trouble later on, or you don't have to loosen it later on. The back side of this bolt is going to be kind of hard to access, so that's where getting it to where you can sort of wiggle that around without needing to loosen those is going to be a good thing. Now this part here is one that I wanted to bring to your attention because for the longest time it confused the crap out of me. And even though I kind of did mention it to the company, they did not make a wiki change on this. But in the installation diagram, it kind of makes it look like there is a bolt going through the aux plate and then into the NEMA motor bracket. In reality, only one end of the NEMA motor bracket attaches to the aux plate and the other end is free floating. So where the picture makes it look like the bolt goes through both ends, on the other end your bolt is only going through the NEMA motor bracket itself. That little circle you see at the bottom isn't the hole on the aux plate, it's actually the head of the M5 bolt. So having said all that, basically on the NEMA motor bracket itself, the bolt goes through, a spacer goes on top, the L bracket, and then finally just one of the M5 nylon nuts to hold everything together. Just like the other one, this is one that you want to tighten down well enough that you can still swivel the bracket, but you don't want to have it loose because you will not be able to access this later. So tighten it down well enough that you can still slide that L bracket around, but don't over tighten. Once you have your L bracket attached to the motor mount, you then want to attach that assembly to the aux plate itself. And this is basically just one bolt, a spacer, the motor mount, and finally another M5 nut on the other end for everything to swivel. Again, you don't want to over tighten it. You want to be sure that you can still move it back and forth, but you can't access this later, so make sure you tighten it well enough. And now for step 4, more parts. This is actually a continuation of 2.1 part 2. So now let's go ahead and get that attached. This is another thing you will notice in item number 3. It says an M5 55mm or 35mm. Previously in the older version, there was a larger gear on the motor shaft which needed a longer bolt, the M55. Well, the M5 by 55. However, the system in the current configuration that they sell now comes with a smaller gear and actually needs the 35mm. This was another case where I had bolts, I had the 55mm bolts, so I assumed that those were the ones I was supposed to use here, and I was incorrect. For the US system, the 35mm is the one you need. As was mentioned, in this video here, you see me using the 55mm bolt. That is wrong. We should be using a 35mm. In this step, all we're doing is taking the bolt, sliding the spring on first, placing it through the L bracket on the motor mount, then through the L bracket that's attached to the aux plate, and attaching the nylon threaded nut. And welcome to step 5, where we attach the stepper motors to the NEMA motor bracket. I also did notice that they did add a note about using the M35 instead of the M55. It was added towards the bottom of that section, and that's why I didn't see it originally. In this section, we actually ran into a couple issues. One was fairly simple and resolved by the company. The pinion gears you see here were actually missing the grub screws that hold them in. I sent support a message and they sent me replacements in the mail, so that was pretty quickly and easily resolved. The other problem that we ran into is that these pinion gears are designed for a 6.5mm shaft, and my stepper motors had a 8mm shaft, so we could not use them. It was actually easier to go ahead and get new motors instead of trying to find another pinion gear, so we decided to go ahead and use a different motor. When I did that, I ran into a new problem because the new motors, the dimensions were slightly off compared to my 8mm motors, and basically when you tried to put them in, it would cross thread. So I just went ahead and drilled out the holes on the stepper motors a little bit, and after that I was able to thread the bolts without any issue. And with that, we are finally through with the beginning of the Y-axis. So welcome to step 6, where we move on to the X-axis. Okay, so step 6 is going to involve a lot of little steps and little parts. While this is the X-axis, it's really the X and Z combined, because we're using the other aux plates, the remaining aux plates, to go in and sort of build out this assembly that is going to connect up both of those. So yes, there's a lot of small parts here. I will do my best to sort of narrate through these as I'm going through to kind of hopefully give you some value seeing this. So in part one, all we're actually doing is attaching the two plate spacers to the actual aux plate itself. This is actually a very small step, and just attaching those two spacers with 6 screws is all this step contains. I did make note that their numbering convention can be a little bit weird. So in the first step of this, it was 3.0 part 1, and this you would think would be 3.0 part 2, but no, this is 3.1 part 2. So the numbering convention that they use in their wiki can be a little bit confusing sometimes. Either way, the next step is very similar to what we did with the initial aux plates. We're going to basically be installing screws for the axles with the spacers, the wheels, and the eccentric spacers. So to make my life a little bit easier, as you can see, I basically just put in all of the screws that are being used as axles, turned it upside down, and then started putting all the pieces on. So the part that we are assembling right now is basically what holds your Z-axis. So this actually holds your 20 by 60 extrusion rail that your spindle attaches to. So the 20 by 60 extrusion rail is going to fit between the wheels that we are installing here. So it's a little bit different setup than we were doing previously. In this case, there's only going to be one wheel and a different combination of spacers and shims. But it basically is very similar to the previous process that we did, in that it's just going to be spacers and shims and a wheel onto the bolt. And once you complete the process of putting on all of the spacers, the shims, and the wheels, in this case there is no back plate, so you're going to go ahead and attach the M5 nuts with the nylon locking threads to the assembly. Same thing as before, you don't want to over tighten these, but you want to make sure it's tight enough that you're not going to have to do anything else to it, because it may be hard to get to these. And on to step 7, more parts. So in this part, we're going to start assembling what is essentially more of the Z-axis, putting in the Acme thread block. This first part is fairly straightforward. Basically, all we're doing is taking a couple of the M5 nylon threaded nuts. And I hope by now you've just gotten used to me butchering and renaming that part every different time I say it. So you basically take a couple of those M5 nuts and put them into your Acme block, and then we attach it to the aux plate with a couple screws. Just a real basic connection, couple screws, and that's it. And welcome to our step 8, 3.2, part 3, the redo. In this step, we continue to install some additional parts onto the Z-axis, or as they call it, the X-axis gantry assembly. We now connect one of the stepper motors to the other aux plate. This is actually going to be the motor that drives the X-axis stepper motor. Basically, all we're doing in this step is attaching a motor to a plate with 4 screws. There's going to be a spacer between it, and that's basically it. One thing you'll notice is that the holes are adjustable, so you can actually adjust the motor up and down. Doesn't really matter where you put it for the most part, because later on when you install the belt, you're going to size the belt up for wherever the motor is sitting. One thing I did note is that as the Z-axis comes down, it will hit the top of the gear that is on this motor. So you might want to install this motor as low down inside the aux plate as you can get it. So basically just let it fall as far down as you can get. But that's just an observation. I don't know if it's going to fit every scenario. And I think I pretty much put mine about dead center, since I wasn't sure at this time how it was going to play out later. Another thing to try and be cognizant of is the fact of where the wires come out. So the stepper motor is basically a square, so you can orient it with the wires top, bottom, left, and right. you may want to start thinking ahead about how you plan on laying out your drag chains and how you want those wires to flow in. It can kind of work no matter where you put it. You can route it, but to make it the cleanest way possible, you may figure out, oh, if I pull it to the side, I can put my chains here and just slide it right in. I put mine on the very bottom, and once I got to my drag chains, I kind of wish I had put it to the side facing where the drag chain was going to attach. So it's definitely one of those things of you may regret your decision later on, like I did. But it's a fairly easy thing to fix. These bolts are fairly accessible. So it should be something you can change after everything is assembled if you don't like what you've got set up. Another thing that's very good to be wary of, the holes, the bigger holes inside the aux plates, the ones designed to, like this one here, those things are actually very sharp. As you see here, I basically was testing to make sure the motor spun correctly, and doing that spinning operation, I basically hit the side of the aux plate and actually cut my knuckle. So it is very sharp if you hit these edges. I mean, they're not like a knife, but in the right situation with thin skin, you can hurt yourself. Now that that's together, the next thing to do is to go ahead and put on the pulley that your timing belt will ride on. And one interesting side note, when you're reading the wiki right now, it kind of never actually tells you to put this pulley on. You just happen to see in the next picture that it's already attached. So like I say, it never really tells you to install that, but it's kind of self-explanatory when you see the next picture and you see it on. So yeah, go ahead and put that on. This is one thing where you can't really perfectly guess where it needs to go because it needs to line up with the track on your rail so that the belt rides correctly. And earlier when I showed that this pulley would hit the Z-axis when it comes down, it's possible that there's some free play in mine that I can actually move that back a little bit so that the Z-axis doesn't hit it. I'm pretty close to the point where it's going to hit the limit switch anyway once that's installed, so I don't think it's going to gain me much to change that, but that is something I need to keep an eye on, so I may be able to kind of push that back. So you'll sort of, don't worry about placing it right now, just get it attached, and then you can adjust that later on. And now on to step 9, 3.3 part 4. This is basically where we connect the two halves, the two aux plates together, and that's going to be connected via the wheels. So this part will be very similar to the Y-axis that we built earlier. So basically this mimics the other process very similar, but instead of using the two aux plates we used earlier on the Y, we're using these two aux plates that are dedicated to the X and partly the Z. So basically you're going to have your long bolts going through that are going to serve as axles. Then you're going to have your spacer, your shim, your wheel, a spacer, a wheel, a shim, and then likewise, just like before, you're going to be using your standard spacers on the top and your eccentric spacers on the bottom so that you can adjust the width of the wheels. Once all of those are on the axles, then you'll basically put it through the other plate and tighten it down with the M5 nuts. Once you get all 4 bolts through both of the plates and get the nuts attached, you'll basically tighten everything down the same as we've done in the previous steps using the Allen key and the wrench or spanner if you're from Australia. Again, you're tightening it down enough that you can still move the eccentrics without having to loosen everything up, but tight enough so that it doesn't feel loose. So it's sort of a, you can play with it to figure out exactly how tight it needs to be. And now on to step 10, where we officially enter what they call the Z-axis. So you're still working with the X-axis gantry, but now you're working on the parts more specific to the actual Z-axis. The first thing we're going to do is go ahead and mount the stepper motor to one of the threaded rod plates. Basically, this is a very simple thing of putting a bolt through the plate, through a long standoff spacer, through the stepper motor, and finally securing it with an M5 nylon nut. There are 3 of these that will hold the motor onto the plate. During this step, you will also need to install your motor coupler. This is basically a flexible piece of aluminum shaft that connects your stepper motor to your Acme thread to help prevent binding and things like that from causing issues. Okay, step 10, more parts for the 4.0 Z-axis assembly, part 1. To be honest, this part of the assembly process was one of the most annoying ones to me. Almost everything in this kit is an exact match. Very little requires adjustable pieces. This assembly uses adjustable screws on both ends of these threaded rod plates so that you're having to keep track of like 6 or 8 total screws in a threaded plate with adjustable holes on both ends while you're trying to tighten this thing down, getting the bearings centered inside of the bearing holes. There's a lot of moving parts that all have to fit together perfectly before you tighten these down. And this was just one of the most frustrating things to me, especially when, because had started building my own kit already, I went out and purchased a 40 by 80 C-beam that was already created. It was a Z-axis kit, basically. It's like all you did was attach a motor, bam, done, walk away. And I really wish they had used that with this kit. And in fact, I may even look at trying to switch mine over one day, mainly because it gives a larger mounting surface for your spindles. But yeah, just know that when you get to this part, it's an unforgiving process. Like, you really have to spend a lot of time and effort making sure all of these bits and pieces line up correctly. So this will need the most attention of anything in this project, I believe. Okay, so we start this step off simply grabbing the 20 by 60 extrusion rail and attaching the motor and motor plate combo to it with 3 screws. Again, as I was saying earlier, these are adjustable plate holes, so for now, I just attached the 3 screws through and left them loose, because as you're attaching the rest of this, you'll find out that you need to do a lot of adjusting. So I snugged them up just enough that I could slide the plate, but it wasn't flopping around. On to step 11, 4.1, part 2 of the Z-axis. So now's when things start getting, as Marty McFly would say, a little heavy. These are assembled components, have a lot of weight in the motors, so just be wary that things can fall over and break easily if you aren't careful. As you can see, we start off by installing the actual Z-axis into the previously assembled X-axis components. If your Z-axis is too loose, or if it's too tight to slide up between the wheels, this is where you would turn your eccentric spacers in order to loosen and tighten those. Basically, the flat side is going to be facing away from the rest of the components. Now you take your Acme lead screw and you start threading it into the nut block that was previously attached to the X gantry component. On the end of your lead screw facing your stepper motor, you actually will put on both a collar and a bearing. The bearing will go toward the actual plate, and then the collar will push against that to hold it onto that plate. The collar has a set screw to actually attach it to the lead screw. Definitely do not over tighten this. You don't want to have to put an indentation into your screw, especially in case you may be adjusting this a little bit. And right now it's probably a good idea just to put a little snugness to it, but you're probably going to have to adjust this as you start doing the other pieces. That screw, there is, again, getting back to an earlier conversation, this isn't a thing that's exact. A lot of this is adjustments, and you really have to get it tuned in before it's really fitting correctly. In fact, one thing you'll see me basically fighting with is that I put my screw through. And what I discovered was that the Acme lead screw was not parallel with the extrusion rail. So when the other end of the plate goes on, it's got to line up perfectly inside of that bearing. But technically in the steps, you're supposed to be tightening down this one end. But until you can put the other plate on, you don't really know where those adjustable screws need to line up. So you'll kind of see me fighting with that here, where I'd go ahead and tighten them down, but oh, then my screw is not exactly level, so then I got to loosen it and lift it up. But because the plate, all three screws are adjustable, then is the plate actually perfectly perpendicular and 90-degree angle with the actual extrusion rail itself. So again, this was the most frustrating part of this project, was trying to line up those two end plates and get the 6 screws tightened down in a way that ensured that the Acme lead screw was perfectly parallel to the extrusion rail, and the metal plates were perfectly parallel to the extrusion rail as well. So again, this is the part that is going to take a lot of tweaking and adjusting to get it correct. Which brings us to step 11, more parts, which is just installing that other plate on the other end. And again, as I was mentioning, you have to have the Acme lead screw parallel on both ends, same height off of the extrusion rail on both ends. And that is something that you're going to have to do a lot of tweaking to accomplish. It is possible to wind up having the system look correct, but actually have a lead screw that is not parallel to that extrusion rail. And this is pretty much just a mirror copy of the last time. You basically put on a collar, then the bearing, then the plate, and attach it with 3 screws. And as you heard me hemming and hawing and spending an exorbitant amount of time mentioning, this is where you have to do all of your adjustments. So once you put this plate on, this is the time to start doing all of your measurements. Check the Acme lead screw distance from the extrusion rail front to back. Make sure it's the same. Make sure that lead screw is parallel to the extrusion rail. Check the plates on each end and make sure you've got the same amount of overhang on one side as the other. Make sure that the plate is truly parallel to the extrusion rail. So this is the point. Once you get these last 3 screws installed, this is where you need to do all of those adjustments to make sure everything lines up perfectly. And with that, we finally move on to step 12, which is where we finally start putting the system together. So at this point, we have pretty much completed all of the sub-assemblies, the smaller components. Now we're going to start moving into the bigger components, where we start putting the actual frame rails together and mount all the components that we just got through building. In fact, I'm going to go ahead and use this moment to break this video up. This has already been, as I'm sitting here editing, we're already 30 minutes in. And the next step, we sort of went down a rabbit hole, and I want to actually start going more in depth into that issue. In fact, I'll give you a little bit of a teaser right here. As I was starting to assemble everything, that's where we first discovered a thing that I missed during the unboxing, and that was that some of the extrusion rails were missing the threading. So I had to reach out to the company and get that resolved, and there's a little bit of a story there, including some videos, so I want to go ahead and go more in detail on that, but it's just going to make this video too long. So we're going to go ahead and break this video right here, and so everything's already recorded. I just got to start editing it. So not too much longer, you'll get the final piece of this project. Welcome to another episode of Fireside Tales with the Lion. Today's episode recounts the tale of that's when the fight started. So you see, what happened was we needed something fixed on an overlay.
By we, he means he.
By we, I mean I. And I told the wife, and she's like, I don't care about you.
That is not what happened. I said,
I'll get to you tomorrow.
I said, I'm really tired. Can I fix it in the morning?
And because I cared,
He
I
said,
decided, I can fix this myself.
that may have been what in your head, but your mouth said.
Actually, my mouth didn't say anything.
No, you
because
said.
I just went in
No.
and fixed it.
Your mouth said, that's fine.
Which, yeah, that's fine. I can fix it myself. So, I fixed it. ...
I
loaded up paint. I pulled my thing in. I drew my arrow that I needed. Boom! Problem solved.
Fast forward 3 minutes later, he says, never mind.
Never mind, I fixed it. And I did. And it looked fine.
And I said,
perfectly fine. And then she said, "Nya, nya, 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 nya."
I said, how did you fix it? And one word caused a fight.
Paint. Duh. Arrow. Done.
Now, his wife runs the Canva classroom.
And instead of making her waste 30 minutes of her time putting an arrow on something, I wasted 10 seconds in paint going.
I actually wouldn't have even put an arrow. I would have put a man finger pointing. But
How do you know it was a man's finger? Maybe it was a woman's finger.
Because I was so irritated, I grabbed the first arrow I could find in Canva, threw it on the darn thing, and then...
My arrow looked perfect.
No, it did not. It looked like a paint arrow.
It looked perfectly... It was black and white text. All I had to say is, see that part right there? All I needed was a paint arrow.
No.
I didn't need a 30-minute Canva dissertation.
And here we are 2 weeks later still fighting.
Still fighting about it because my arrow looked fine.
It did not. It looked terrible.
Fine. Like your arrow looks any better. It's still just a black arrow. It looks the same as mine.
Anytime he wants to get me riled up, he uses one word.
Paint.
And I'm not talking about what should go on the walls.
I mean, hey, there's a reason MS Paint is still in Windows, because it works. I mean, in fact, is Solitaire even still there? I think Solitaire is gone now, but Paint, still there, still works.
Canva.
$130 a year program. Do it more.
May I just say that I did something and you're like, okay, that makes it worth it.
Oh yeah, that was that one thing, but that's a different argument.
All right.
My arrow was fine. We're going to show them. I'm putting these arrows at the end.
No.
You're going to see these two arrows.
Nope, here's the deal. We've got the community tab.
We're going to do a poll. And it's not going to say which arrow is better. If anything, it's going to say, is it worth 30 minutes of time to make this arrow over this arrow?
It took me less than 2 minutes.
Whatever. Took me less than 2 minutes too. And I didn't have to go to somebody else's website. I can do mine offline.
You got me riled up so that I could not sleep. That's what paint did for you.
Well, if you couldn't sleep over that little tip, that's your problem.
Not the tiff, just the fact that my husband would consider using paint as an overlay. Now that's not to say that I didn't use paint when we first got started, but I learned that I could use Canva. This was the woman who made an animated wallpaper back in the 90s. This was the 90s. We're in 2020.
Animated wallpaper. The entire background was moving.
It was an earth.
No, it's when you made Winnie the Pooh. It was like Tigger bouncing on his tail, but it was basically tile, so there was like 100 Tiggers, and they're all bouncing behind the text of the website.
I'm laughing so hard the camera's moving.
Animated background. Enough said.
By the way, we don't really get in fights. We get little tiffs, and then I would call them a spat.
Yeah,
we get little spats.
A disagreement.
Because they can be diffused with the use of a spatula.
I don't even get that reference.
We gotta cut this blooper.
Why? Because it's longer than the video now?
Yep.
So please stay tuned, and if you enjoyed watching this and kind of want to see the conclusion, please go ahead and subscribe, do all the usual things, and we will see you in the next video.
Is it over yet?
The first half is.
What do you mean the first half?
My projects last a long time.